Okay, so today, let's see, we are doing 10.5. That's right, 10.5. Okay, so before spring break, you learned about the bar graph, the circle graph, etc., etc., etc. So today we are learning about the fundamental principle of counting. It's not difficult. And you will have a quiz tomorrow. Yeah. Huh? I will not make it hard. Okay, so all you need to do is before the quiz tomorrow, you need to kind of go back over 10.1, 10.4. Just go back over it, okay? Look over it. Take your book home, kind of thumb through it. I'm not going to make you create a circle graph on the quiz. Maybe on the test I will, but not on the quiz. It's going to be like reading a circle graph or reading a bar graph or something like that. Okay, fundamental principle of counting. Okay, you can do one of two things. You can do what's called a tree diagram. It is used to find all the possible outcomes. So let me back up. Okay, so today's objective, the fundamental principle of counting, basically it's okay. We go to Menchie's and you have choices of your bowl, what size bowl, right? Or a cone. And then you have choices of the flavor of ice cream, right? And then you have choices of your toppings, correct? Okay, so the fundamental principle of counting is trying to find the total amount of possible outcomes, or choices, I should say. And you can do that with clothes. Like when I go shopping in August, or you guys for school, you can have 3 pairs of pants, maybe 5 different shirts, but that doesn't mean you only have 3 outfits or 5 outfits. You can have like black pair of pants with a red shirt, black pair of pants with a pink shirt, black pair of pants with a blue shirt. You see what I'm saying? So each one of those is an outfit. So when they say the possible outcomes, we're talking about, given this information, how many total choices do you have?
That can sometimes be kind of hard.
Ah, yes it is. However, watch this. Let's say, here's an example. We're going to jump right into examples. And yes, it can be hard because your mind is blown. Let's say you're given possible first digit number is 1, 3, or 5. So the first possible digit of a number can be either 1, 3, or 5. The possible second digit number is 0, 2, or 4. You know, like if you were doing a code or a password or something like that. And let's say it's a 2-digit password, and you could choose only 1, 3, or 5 for the first digit, and for the second digit, it's going to be 0, 2, or 4. So the question is, how many possible outcomes or choices can you have? So let's use a tree diagram first to figure this out. So for the first digit, what were your choices, Joseph? 1, 3, and 5. For the second digit, what are your choices, Atalia?
0, 2, and 4.
So then we would have 1 and 0, 1 and 2, and 1 and 4, right? So then we could have 10, we could have 12, or we could have 14 as your password. For 3, we could have 0, 2, and 4 as your second digit, to where your password would be 30, 32, or 34, right? Y'all get where I'm going with this? And then for 5, same thing. Your choices would be either 0, 2, or 4. So then your 2-digit password would be either 50, 52, or 54. I'll let y'all catch up. So how many total choices do you have? Atalia? That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be your answer. 9 total choices. Any questions about the tree diagram? That's a lot of work, right?
Not really.
I have a question for you. Look up here, Joseph. How many choices did you have for the first digit? How many choices did you have for the second digit?
3.
What's 3 times 3? Ooh, I see a smile on someone's face. So, do you actually have to do all this work?
Does that always work?
Yep,
That's exactly what we're doing.
that's exactly what y'all did.
Okay, so no.
Okay, now I will tell you, I just taught this to the 6th grade.
We never learned that last year.
Come on now.
We learned that, but we didn't learn like
The easy way?
Yeah.
Oh, I'm sorry. So, the 6th grade, I taught them both. Every one of them did this. Even on your test and quiz, it may say, draw a tree diagram, da, 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 and I'll even write on there. You can draw tree diagrams if you want, or you can do this method.
I might do both just to make sure,
You could.
because I don't always trust it.
No, I understand. I understand. Okay, let's do another one.
Will it always be 1 through 5 and 0, 4, and 2?
No, man. So, for example, let's say, okay, let's go back to Menchie's. Okay, so what are your choices for serving dish?
2, 4, and 6.
No, for Menchie's. Let's say you have a small cup,
Oh.
large cup, or you have a cone. Okay, at Menchie's. How many flavors do you think there are? Just guess.
What do you mean?
How many different flavors of ice cream or frozen yogurt do you think they have?
Have Menchie's?
Yeah.
12.
He says 12. So then,
It's 3.
for flavors, you would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Gracious.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see where I'm going with this? And then if you had toppings, you would have, let's say there's like 10 toppings. So each of these little things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
With those branches?
1, 2, 3, 4, 5, 6. Okay, do you see why a tree diagram is crazy?
Oh, yeah.
How many choice for servings? 4. He said 12 flavors.
But there's 3.
I mean 3. There's 3 choices for serving thing. He said there's 12 flavors for ice cream. How many toppings did we say? 10. Multiply all those together.
260.
Is she right?
I think.
Do the
Wait, no,
math.
240. Wait, no, 260. Yeah,
I want Joseph to do it.
360. Yeah.
Joseph, you do it and check her.
No, yeah, 360. Yeah. Sorry. I did. Yeah, 360.
What's 4?
Because 3 times 10 is 30.
Wait a second. No.
10.
Look, or you can do 3 times 12. It doesn't matter. But multiply these 3 together. I'm not asking for much, man, but it is Monday after spring break. I'm not saying you're wrong.
360, right?
I'm having him check your work.
Why?
Because I need his brain to work this morning. No?
216.
Huh?
216.
For all 3 of these? Joseph, what's 3 times 10?
3 times 10 is 30.
So now do 30 times 12. There. Now he's awake. That's how, see, if you do the tree diagram, do you see how crazy it can get? Or we could walk into Minchie's right now and count how many servings, how many flavors, and how many toppings, and boom, right there, do the math. You have 360 total choices when you go to Minchie's. You don't just have 3 choices or 4 choices. You inevitably have 360 total choices.
Doesn't that mean that you could have 360 different combinations as well?
Yeah, that's the same thing.
Oh my gosh.
Yeah. So that's the objective today, is to make sure you understand that. This can be applied to everyday life. Let's do another example. How about if you go to the store and you buy 5 shirts, 2 pairs of pants, and Joseph buys 3 ties. He's a fancy man.
Yeah.
Now, instead of doing the tree diagram, we'd do 5 shirts and then each one be 2. You know what I'm saying? Instead of doing that, Joseph, how else can we figure out how many total combinations?
We can do 5 times 3 times 2.
Yeah.
10.
So, Joseph, what would you get?
30.
30 total choices. Yeah.
I spelled total Tatol. Total instead of
Tattoo.
instead of Tota. Tatol.
Okay, so do we understand what we're doing here? Huh? Yes? All right. So, the tree diagram, do you have to do it? No, not always. Because look at this. This would have gotten ugly. This would have gotten ugly. Sometimes you need that visual. For this one would have been an easy one to do with the tree diagram. But in the real world, go to Mod Pizza. How many total choices there? Well, do it.
36.
Right. Doing a tree diagram would not be appropriate. So go ahead and open your books to page.
It would be a mess.
There's like 10 different veggies.
I know, right? So that's what I'm saying. If you multiply all that together, you get your total choices, combinations, possible choices.
100 and not 200.
I tell you, open. So that's why drawing the tree diagram would be insane sometimes. So just multiplying all your choices together, there you go. Don't tell me about your dreams. Open up page 422. All right, number 2. Natalia, you're first. It says make a tree diagram, but you do not have to make a tree diagram. So, Natalia, read it.
There are 3 candidates running for mayor and 5 running for a vacant county council seat. How many different ways can these seats be filled?
All right, so how many candidates are there for mayor?
3.
How many running for the council?
5.
So you could do a tree diagram, or 3 times 5 gives you 15. There's your answer. The biggest problem's going to be, and this was with 6th grade too, the biggest problem is reading the question and figuring out what they're asking. Like, just like kind of dissecting the question and saying, okay, they're asking for 3 mayor, 5 council. You could do tree diagram, but why bother? Okay, let's do another one. Because I think y'all understand that. Maybe we need to do a couple of extra stuff since y'all seem to be tired. Look at number 4. Joseph, read number 4.
There's apple, cherry, blueberry, and peach pie to choose from. There's vanilla and cinnamon ice cream to choose from. How many ways can you choose a pie?
Pie a la mode. Pie a la mode means pie with ice cream on top. So how many choices of pie do you have?
4.
4. How many choices of ice cream do you have?
2.
So 4 times 2 is?
8.
Very good. Look at number 6. Natalia, read it.
How many ways can you choose between 5 colors of socks and 3 pairs of shoes? 15.
5 times 3 is 15. Do you understand? Any questions? Speak now, forever hold your peace. You have a question? Joseph? All right, look at 16.
Oh.
We're moving it up a notch. All right, I tell you, looking at it, it says flip a coin 3 times in succession. Ooh. Flip a coin 3 times in succession.
Well, it's like a 50% chance.
No. How many sides are there to a coin?
2.
So 2 sides to a coin. How many times are you flipping it?
3.
So this is going to be different. It's not 3 times 2. Your first flip, look what I'm doing. First flip. How many choices do you have? Joseph? If you flip a coin, how many possible choices do you have? 2. How about the second flip? You flip it a second time. How many choices do you have?
2.
And it says you flip the coin 3 times. How many choices do you have?
2.
So look here, guys, because this is different. 2 times 2 times 2 gives me what? Joseph.
16.
2 times 2 is what?
8.
Okay.
I thought that's pretty
Y'all see that this is a little bit more, scary?
It's not. Oh, wait, yeah.
Let's go back to 14. Natalia, read that one.
1 is followed by a
Okay, so how many numbers are from 1 to 10? There's 10. And then it says, then flip a coin. So if you flip a coin, how many choices do you have? Huh? If you flip a coin, you have 2. So 10 times 2. Huh? 20. I tell you, sit up. All right, any questions?
Yeah.
What?
What's the difference between 14 and 16?
Well, this one, because it says you're flipping a coin 3 different times. And each time you flip a coin, you have 2 choices. Here, they just said choosing a number 1 to 10. Well, there's 10 choices, and flipping a coin, there's 2 choices.
Oh, I thought you were flipping it. Wait, so you're flipping it 2 times?
No, that's why I need you to sit up, okay? Because it says flipping a coin 3 times. How many choices when you flip a coin? How many choices possible? There you go. The second time you flip a coin, you have 2 choices: heads or tails. Heads or tails. So then you multiply that. All right, 18. That's why I said to sit up. All right, Joseph, read 18.
Choose an hour during the week for an event that can occur any hour of the day, any day of the week.
Okay, choose an hour during the week for an event that can occur any hour of the day, any day of the week. So it's like, okay, for 1 hour, sometime in the next week, I need to wash my car. Okay, so to choose any hour during the day, any day of the week, how many hours are there in a day?
4,
How many days are there in a week?
7,
24 times 7. Joseph, tell me what you get. And Natalia will check you.
160.
What?
160.
Very good. All right, Talia, you can do the last one, number 20. Read number 20. Okay.
There are 10 names in a hat. How many ways are there to draw 3 names for first, second, and third prizes from the hat, assuming each person can win only 1 prize?
Okay, so each person can only win 1 prize. So it says first place. How many choices do we have in the very first drawing? Atalia? Well, we're looking for first, second, and third choices. So if you put the names in the hat, you're drawing someone for the first. How many choices do we have for the very first drawing? 10, that's right. They put 10 names in the hat. So for the first drawing, you have 10 choices, right? Now, here's the clue though. Here's the kicker. Assuming each person can win only 1 prize. So like if Atalia was the winner for first, can she be put back in the hat for the second place?
No, please only.
So there's only 9 choices for the second. And Natalia, how many for the third choice? That's right, because these people that won first and second can't be put back in.
I need to do something like that then.
Oh, yeah? So then multiply all 3 of these together, Natalia. What do you get?
720.
Yep. 720. You think y'all good?
No, I still don't understand 14 and 16.
Okay, well, 14 Go back to 14. It says choose a number from 1 to 10. So you have 10 choices for that one, right? And then flip a coin. How many choices do you have? When you flip a coin?
We're not flipping a coin one time.
Yeah.
Oh, okay.
Do you get it now? Okay.
So what if we wouldn't have picked 10?
Huh?
What if you don't pick 10?
Well, it said to pick 10. Pick a number
from
from,
1 to 10.
yeah. 1 to 10. 1, 2, 3, 4, 5, 6,
Oh,
7, 8.
Pick a number, like just pick a random
Yeah. A number from 1 to 10.
one. So what if we didn't pick 10?
You had to pick 1 to 10.
What do you mean? No, I'm saying like, it says to pick a number from 1 to 10. So what if I were to pick 7 instead of 10?
I know. How many choices do you have between 1 and 10?
10, but it says to pick a number from 1 to 10.
Yeah, any number. Like when I'm sitting there going, okay. Whoever gets closest to the number I'm thinking wins a prize. And you can choose any number between 1 and 10.
You didn't have to pick 10.
That's right. You can pick 3. You have 10 choices. Huh? You can pick 7, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have 10 choices to choose between 1 and 10.
I know, but it says to pick a number from 1 to 10.
Yeah.
So what if we didn't pick 10? Would we get a different answer?
No, it's
No.
not saying
They said pick any number.
You have 10 choices.
You
I know,
you
but
pick
it's
any
not
number
choices.
between 1 and 10.
But it says to pick a number from 1 to 10.
I know.
So what if we didn't pick a number? What if we didn't
You
pick 10?
you have to pick a number between 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are your choices. You have to choose a number, these numbers, between 1 and 10.
So you would get a different answer for
Nope. How many choices do you have to pick between 1 and 10? There you go. All right, you're going to do
10
page
choices.
Yeah, list how many choices.
422 to 423, numbers 1 through, right, Joseph.
Is it asking how many choices you have to pick?
You have 15 problems.
That makes sense. I didn't
So
understand
1
that.
to 15.
I thought it was just saying pick a random one and then.
No, pick any number between 1 and 10.
Right, but you're saying it's asking how many choices do you have between 1 and 10.
Yeah.
I didn't know that's what it was asking. I thought it was saying just pick one, like pick a number from them and then multiply it by 2. Like if I were to pick 7 instead.
Oh, no, they're asking just your
That's what I was
choices.
asking.
Oh, okay. All right, you have a quiz tomorrow, and this work is due tomorrow.